Right, we're going to take a look at another proof using some overlapping triangles. So let's figure out what we're given, mark up our figure, and go from there. So first thing is that given FP is congruent to MR. So where's FP? Here's FP. It's this big side right here is congruent to MR, which is that big one over there. So those are congruent. I'm not necessarily marking the congruency right now because, you can see we've got this other G somewhere there and this line coming in. It might get confusing. So I'm just going to do those little bracket thingies to kind of denote that those are congruent. That's kind of in my head. I'm keeping that in mind. Okay. Blah. So also we know that G is the midpoint of FP. So if they're telling us that G is the midpoint, what does that mean? Well, remember, a midpoint divides a segment into two equal parts. So that means that FG and GP will be the same. Alright, they also told us that K is the midpoint of MR. Now let's see if this makes sense. If FP, this longer segment, is the same length as MR, and G is a midpoint and K is a midpoint, do you think that these shorter segments on both sides will all be congruent to each other? And hopefully you're saying, yep, that makes sense. We think that MK and KR are also congruent, and I'm giving all of those just one of those dashes because they all four are the same length. Alright, then we also are told that angle GPR is congruent to angle KRP. So GPR, here's G to P to R, so it's this bigger angle right there. So I'm going to go ahead and mark that. That bigger angle is congruent to angle KRP, which is this bigger angle right there. Okay, and then we want to prove that GP is congruent to RK. Actually, we're going to change that. So if this is not changed in your note packet yet, I apologize. I forgot that was a change we had to make. So GR is congruent to KP. That's what we are trying to prove. And then down here, I'm going to go ahead and make that change because that's going to affect our last line right here. That's going to be GR is congruent to KP. Okay, back to our figure. So, we've got this, it's actually kind of looks like a trapezoid, but we're talking about, a chapter where we're using triangles. So do we see any overlapping triangles? And we do have these two triangles down here that are overlapping. If we were to draw those out separately, maybe I'll draw those out down here so we can just kind of see here's what the two triangles would actually look like. There's one of them. Here's G, P, R, and I do recommend drawing this out in your own notes as well, just so when you look back at it, you can see how we separated out the two triangles. Hopefully you guys are drawing these a little bit better than me. K, R, P. And then what are our congruencies? We know that GP is congruent to KR. We know that this angle P is congruent to this angle R. Alright, so those are our two triangles. Let's go back to our proof and start filling some of this in. So FP is congruent to MR. Basically these three things were all given to us up above. So I'm just going to do one of these and say that those three are given. Kind of a little lazy, but that's okay. Alright, now we can go ahead and say that GP is congruent to KR. Now, we just have to make sure we understand the reasoning behind this. So if we go back to when we did that, we had this big segment that got divided into two smaller segments. And this bigger segment that was congruent got divided into two smaller segments. So, because these long segments are both congruent to each other and they're divided in half by the midpoint, then the divisions will be congruent. So these smaller divisions of the longer segment will also be congruent. And that's our division property that lets us make that conclusion. Alright, so you notice I just went ahead and actually wrote that out for you guys. That might be a good thing to just add off on the side, just so we remember how that division property helped us out in this proof. Alright, so next we have that these two angles are congruent, and that came from the given information up there, so that's just given to us. Don't you love all the given information we have? Alright, so at this point we have, if you look at our triangles down here, we have a side, a pair of sides that are congruent, and a pair of angles are congruent. So we need one more thing that will let us do a triangle congruency. So things to keep in mind are any shared sides or angles. Did you guys notice if these triangles have anything that's shared? And that's going to come from the original figure up top. You might notice that they share this bottom side of the triangle PR. So we can go ahead and mark that congruency. PR is congruent to PR, or you can mark it up here as well. And that's going to be our next statement. I'm going to say PR is congruent to PR. And that is our reflexive property. So at this point, what do we have in terms of using our triangle congruencies? If you look at the figure below, it's a little bit more clear. You have a side, an included angle, and a side congruent to a side, included angle, and side. So that is our side, angle, side. So we can go ahead, we have enough information to say that the two triangles are congruent. So triangle GPR is congruent to triangle KRP, and that's from our side, angle, side congruency. And then our last step 8 is, this was what we were trying to prove, that these two sides are congruent, that GR is congruent to KP, and we're able to say that those are congruent now because of our CPCTC. Once your two triangles are proved as congruent, then you can follow that up with any corresponding part being congruent. Sorry for that kind of long proof, but hopefully we're okay with it.